record. Hey everybody, today we're going to be looking at making a game in Python, and the specific game we're looking at is going to be Tic-Tac-Toe. Let's start off with what is going to be necessary for this workshop. I think it's super important that you guys open up the Python docs for Turtle graphics in the background. That's going to be super duper important because we're going to be working in Turtle quite a lot today. So starting off, what is Turtle? Turtle graphics is basically a part of the Python standard library that was initially introduced to younger programmers to get a beginner level experience with Python graphics. So that's going to be fairly interesting and fairly useful today. Though initially we kind of were looking at spirographs for Python graphics, like that was basically the point of Turtle. Nowadays we can do basically anything with Turtle, and it's really quite simple and it's really intuitive. So I figure that this would be easy for anyone who's either a beginner to Python or a beginner to Turtle specifically. We're also looking at keyboard input. So for keyboard input, we're going to be looking at using QWE, ASD, and ZXC on the keyboard. And this is how it would look as part of an actual tic-tac-toe board. And I guess from there, it's quite intuitive on how it's being used. When you press Q, your X or O respectively will end up in that part of the keyboard. On that part of the tic-tac-toe board. So yeah, we're also going to be working with idle. So I find that the reason we're using idle actually today is because it's quite easy to work with. You don't have to do too much extra downloads. And I think you'll find, just like I do, that idle is really fun to work with. And it's not too hard on anybody, really, especially for beginners. There's not extra downloads. So let's begin with the workshop. All right. So this is idle. The process of creating a new file in idle, just so that you guys know, if you don't already know, you're just going to go to File, New File, create a new file and put it wherever you want. Right now, mine is on my desktop just because it's really easy to access from there. And we're going to start off with importing Turtle and creating our tic-tac-toe board. Okay, let's pull up the tic-tac-toe board once again because it kind of went away. There you go. So the tic-tac-toe board is declared like this because I want all zeros in the beginning so that we can change them to different values depending on, first of all, what input we get, an X or an O. And second of all, whether or not that spot is filled. So if the spot is filled, we're going to have it with a different number. But if the spot is empty, it's going to have a 0. So as you can probably see, this would be the rows of the tic-tac-toe board. And these are the columns if you go down. We're importing Turtle because, you need to import Turtle in order to do that, to do any of the graphic work that we're doing in the first place. Okay, so there's a couple of things we have to declare before we can even start this. The first process is declaring the brush. So I have pre-written some of this stuff. You can call this a brush or a drawer. So I know there's a lot of different terminology online used for this, but basically I call it a brush because you're drawing with it. You could also call it a pen, whatever you want to call it. But brush is an object of class Turtle, and you're going to be using it to draw today. Your pen size is just the size that you want the brush lines to be. So what I did was I did size 6 because I figured that looked really well and translate nicely on the screen. Brush.ht, which is the next line you see here, actually hides the turtle, and that speeds up the drawing. And how do you know this? Well, I didn't actually know that at first myself. But what I did was I just went and I searched up on the Python documentation, which we're going to be using quite a lot today. And it basically tells you that it speeds up the drawing. So the next thing that you're going to do is declare a window. And a window is just a screen on which your turtle can draw. The thing is that it's often just called screen in Python, like for people who use Python quite frequently. However, I have a Java background, so I just changed it to window because I figured that was more intuitive. And here is window.tracer. Now, if you're wondering what .tracer does specifically, I can actually show you through going to the documentation, which will be really essential for today because I figure that's a really big part of this. And so this will basically set delays for the updating of the drawings. Okay, let's begin with creating a grid. So we're going to create a grid. This should create the horizontal part of the grid first. So I'm going to drop in a quick function that I typed up. Now let's go through this rather quickly. So for a grid, for I in range 2, which is going to be because we have 2 lines horizontally, right? At point, and these are the values that I will take on. That's basically what this is saying. The values that I is going to take on is 0 and 1. You're going to put the pen up for the brush, which means you're lifting it up so that it doesn't draw while you move it. Then you're going to do brush.go-to, which is actually physically moving the brush. Negative 300, 100 minus 200i times I. And this is what that actually ends up giving you as a result. So the first time you iterate through this, it's going to give you negative 300, 100. That's where the first line is placed. And the second time you iterate, you get negative 300, negative 100. Okay, why do we have negatives? That's really important to know. Well, actually, it's because the window for turtle ends up starting directly in the center. So your 0, 0 is kind of at the center of the window. You move out past that, but 0, 0 is approximately at the center of the window, which means if you're going negative, you're moving in a direction away from the center. Then you put the brush pen down, which means you're actually ready to start drawing, and then forward. Forward is basically just drawing forward in whatever direction you're in, and we're saying we're moving forward 600. And then brush.right, which is actually changing the direction that you're moving in. And that is going to become a little bit more useful when we do the second part of this function. But for starters, maybe you want to see what this looks like. So let's do that. What does this look like? Okay, so I have the output here. This is basically what it looks like. It's 2 horizontal lines. Now what we're going to do next is basically do the 2 vertical lines. And it's essentially the same process. The reason we changed the direction using right was so that we could actually draw the lines vertically now. So this is basically the same code as above, the brush.pen up. It's just that now the 200i has changed direction, which is fine and fair. And you're starting with negative 100 and 100, and then 300 and 300. And then the brush.pen down, and you're going to have it go 600 down. In that 600, sorry, in the direction. Pen down is just putting the pen actually down on the paper so that you can brush it, so you can see the lines come through. And then you update the window. You must always update the window. I didn't mention that the previous time, I think, but it's really important to update the window. Otherwise, you're not going to see anything. Okay, let's run this and let's see what we get. All right, and this is what we get. A straight down. Yeah, so that's what it looks like. Nice, right? Okay, so the next thing that we're going to do is, now that we've gotten at least our board ready, let's start drawing some shapes. So what we're going to need for an O is a circle. Let's create a circle. Let's create a circle function. What's it going to take in? X and Y, which are the positional coordinates, and radius, which is going to be the radius of the circle. So X and Y will tell you where are we going to start drawing the circle, and radius is basically going to tell you what is the radius of the circle. Now the code for this is, once again, fairly intuitive and quite simple, you'll find, because circle is already something you can use in Turtle. So you already have circle created for you. And brush.circle radius will take in the radius you choose, and it will draw at whatever location you're at. So I told the brush to go to X and Y, which are the coordinates that were given to me. I put the brush down. See, it was up before, but then I put it down and I drew my circle, and then I updated my window. A simple process. And what does that even look like? Well, that should look like this. Let's quickly run that. And that should look, hold up, I forgot to actually write the circle here. Don't forget to do that. It's not going to run unless you actually put the function at the bottom. You call the function, otherwise it doesn't run at all. See, you'll see this is still empty. But if I run now, yep, save it. It should draw a circle. Hold up, give me just a second. Ah, yes, circle is missing some positional arguments. That's because I didn't give it any. All right, so this should give you your 3 positional arguments. Now I want a circle that starts at -50 positionally for x, starts at 0 positionally for y, so it's at the center, and then it has a radius of 50. So what does that look like? Now it should work because I forgot to put in the arguments. Do remember when you're using functions, you do have to put in the arguments. You can't just go like this. Grid has no arguments, so you do have to put them in here. Like you have to put in the arguments for the respective parameters. So now it should work after the nth time. There you go. And then you get your circle in the center. All right. Next thing you'll want to do is actually look into making crosses. Crosses is more difficult though, I'm going to say, is a little bit more difficult than making circles. So what does a cross look like? I'm going to drop in the code now and we're going to go through it real briefly because we've got bigger fish to fry right after this. So brush.pen up will actually pull the pen up and so that you can move. And then once again, go to takes you to a location, pen down so you can draw, and then brush.set heading. So now you might be a little bit confused, like, well, we've never seen this before. So what do we do when we've never seen something before? We go straight to the documentation. We say, what is this? Okay, there you go. So it basically sets the orientation of the turtle to a specific angle. Now, these are the standard ones you're going to be looking at, right? So 0 is east, 90 is north, etc. And this means that when we set it to 60, we're heading in the northeastern direction. Now we're creating 2 brush strokes for a cross. So that means you're going to do for I in range 2. That's a for loop that will iterate through 0 and 1. The brush will go, you're going to move it now forward by 75, and then you're going to move it backward by 150. And then you do the same thing. Move the brush forward again by 75, and then you're changing the direction so that you can cross over it because you want a cross motion. So hence the left with the degrees like told here. And then the second time it iterates, it would have changed direction to left. And then it does all of these again. And then the direction remains at, changes again to left 60, but that doesn't matter because we're going to change the direction of the brush the next time we use it anyhow. So that ends there. And now we're going to do a little bit of testing with that just to see what that looks like. So what does cross look like? And real quick, let's just remove this grid because I don't want to see the grid anymore because it's going to have cross going over a couple of its lines and I don't want you guys to get confused by that. So I'm just commenting out grid, which is something you often do. That's the advantage of having functions. You don't need to comment out the whole block of code. You can just comment out grid, which means it's not going to run. So there you go. This is the X and the O. That's what it looks like. All right, let's head on to changing colors. This is my personal favorite thing to do. However, I noticed that some people actually get a little caught up in the changing colors and they get a little tricked by some of the parts of it. So I thought I would write it out just so you specifically could see what's going on. The instant you run changing colors, the problem that comes up is that it's going to permanently be this color now from that point onwards. Until you change the brush.pen color back to whatever it was before, you're stuck with red. So if you don't like red at some point, you do have to remember to change this. Here's one test that I ran for this. And this was a pretty fun test actually because it showed you the different colors. Let me change that. I'm just going to change that. And I'm going to change that again. And I'm going to remove this because I already have a changing colors here. And we're going to remove both of these just so that we don't have to see them. So for now, I'm just going to backspace them because there's no point and I'm not going to be reusing those. So run the module and let's see what this looks like. So this is what this looks like. We have a circle that ends up being black because we changed it again. Sorry, we have changing colors, which actually creates a cross that is red. So it's inside the module. It's inside the function. And then we change the color back to black and then we draw a circle. If, for example, we didn't have this line, it wouldn't change back to black automatically. Although you are calling it in a function, It's not going to change back to black automatically. You're going to end up with this kind of output. So you do have to have that line in there specifically that changes the color back to black if you want to go back to working with black. Okay, next thing you're going to want to do is look into the keys. So we're actually at close to the end of the workshop where we talk about keys, which is going to be probably the most interesting part and maybe for some of you a little more difficult than the rest of it. But first we have to start with a little bit of a precursor with isEmpty. So we're going to create an isEmpty function, which is going to tell us if a certain spot on our tic-tac-toe board is empty. You have two types of tic-tac-toe boards in this thing. You have the metaphorical tic-tac-toe board, which is basically your array tic-tac-toe board, and then you have the physical tic-tac-toe board, which you've drawn out. So with the metaphorical tic-tac-toe board, I'm just going to write out the code first and explain it to you. With the metaphorical tic-tac-toe board, you must update it at each point. The reason for this is because when you update it, then you can check, is it empty? So isEmpty, if at a certain row and column, the value is not 0, then that value is not empty. That means there's a value there. That means that there's either an X or an O at that point. Otherwise, it is empty, so you can return true. So it's like isEmpty is almost asking you a question. Is this empty? If it is, let me know, and I can put a value there. If not, then I won't put a value there. Okay. Now, next thing you're going to do is add values. So let's do some add valuing. All right. So the point of add values is actually adding the X's and the O's to the tic-tac-toe board. Now, if you remember, if you can recall back to our previous image, but if you can't, I'm adding it here. When we have a Q, we're in the top left of this entire board. Okay. So if that's the case, let me save this real quickly. If that's the case, let's go and do a little bit of keyboard input stuff. So we're going to say that this takes in an input of letter because that's going to tell us where to put stuff on our keyboard. And we're going to say if letter is the uppercase Q or the lowercase q, what are we going to do? Well, we're going to put some value there. So we're going to say if isEmpty at the upper left, put some value. Okay, simple. All right, so we're going to have to put some value there. We know that now. Okay, but what if it's not empty then? Well, if it's not empty, we can put in this statement. Else, remember to enter a valid input. Because that way, you know that it's actually the location. The input itself has no problems with it. The location is the problem. Okay. All right. Let's do another test one. Okay, what if it's not Q we get? What if we get like S? Okay, well, S is at the center of the board. And we're going to use elif, which is else if, because we're only really looking at one input at a time, right? And if that location at the center, 1, 1, because remember 0, 1, 2, 0, 1, 2. So it's 0, 1, 2, it's in row 1, and it's 0, 1, 2. So it's in this is column 1, and this is row 1. So it's in both ones. That means that if that location is empty, then we're going to put some value there. And then afterwards, we're going to go and say, otherwise, if we don't put that value there, like we said before, put in some valid value, some valid input location, right? Okay, so what are we going to do here? This is the thing, like you can't just leave it as pseudocode. We actually have to do something here. So what we're going to do now is we're going to do something called 1x key. And we're going to work with the 1x key, though ultimately for this coding project, you're going to have to do more than that. But I'm going to show you how to implement 1, just so that you know how it works. So I have this function. I'm going to call it 1x key, and it's going to take in a row and a column. And so it starts at 0, 0. So that's hence the note does the proper value 0, 0. And basically what it's going to do is it's only going to put X's, and it's going to put them depending on their column and their row value at this location. Now, in terms of the math, you can actually draw that out yourself, but just know that one X key is going to put the cross at these two coordinates that you've been given. So, and it's all dependent on the input. So you do have to indeed get an input in order for this to work. Okay, well, that's not enough though, right? Because we kind of want another maybe function that will tell us, okay, it's going to update the grid, and it's going to update the metaphorical grid, and it's going to update the actual grid. So the metaphorical grid, as we said, is that grid with the one that's like the tic-tac-toe board, that's like just a double array. So this is the metaphorical one. The real one is the one we drew out, but it's no longer here, but I can output that later. Anyhow, so we're going to go through update grid because we want to update our array. So let's do that. So we're going to give it a row and a column, and we're going to say all update grid is going to do is it's going to change that row and that column value to 1, which means that it's now full and nothing else can put something in there. Hence, that is empty stuff, right? So what we're going to do now is we want something that works with both one X key and update grid. So like you probably already guessed, we're going to create another function. Well, another couple of functions because I want to work with both Q and S and show you examples for both of them. So we're going to call this R1C1, which is row 1, column 1. But you know what? We should probably call it row 0, column 0. Listener function. And what it's going to do is it's going to both update the grid at that location, and it's going to update the X key at that location. So this here will say okay, let me put it in here so you guys actually know what it looks like. What this looks like is actually this. So it's going to say, oh, okay, well now it's 0, 0. This is 1. And it's also going to draw that. There you go. And now we're going to do the same thing, except that now we're going to do it as 1, 1. Right? And what we're going to do for 1, 1 is we're going to update the grid at 1, 1, and we're going to update the X key at 1, 1. There you go. So basically now it's going to say this. It's going to say that our TTT, or our tic-tac-toe board, looks like this. And then it's going to draw that. And it's going to say, okay, now I've drawn that on my graphical window stuff. Now, the reason we don't do a update here is because the actual update should be happening within the cross, right? Because this just calls to another function. So basically, this is just a long series of function calls. So this function is calling to these two functions, which are going to update grid actually does something, but the 1X key just calls to cross and draws the cross at the proper location. And cross already has a window update, so it's not a problem. The next thing that we're going to do is, okay, so we've created our lovely listener functions that are basically going to update based on the information we've got. Our listener functions depend on whether or not this is empty. If it is empty, then we can use our listener functions. So that means at this point here, we can just straight up drop in our listener functions. So let's put one here, and let's put it here as well. And we're just going to change this to R0 because it's supposed to be R0. There you go. So there you go. And it'll tell you enter a valid input location if that's not empty. Okay. So let's see. So basically at this point, what you know is how to draw a grid, and you know how to draw a circle. You now know how to draw a cross as well, and you know how to change colors. You know how to check if an array is empty at a certain location, at a specified row and column. though I should probably write that there is a row and column location here. And you do know how to add a certain letter, like how to check based on a certain letter value if that location is empty, and then consequently drop an X in that location. And you use that based on a bunch of other little small functions that we added in here that all deal with just updating and calling to each other. So you basically know how to run this entire game, but what you do need to learn at this point is how to have both X's and O's. And that becomes a task for you yourself to try out. But let's do a little bit of testing to see basically, well, how does our grid look? How does this whole project look now that we've made at least 8 to 9 changes to it? And what we're testing, because we want to test input as well. So what we're going to do is we're going to use input from Python, and we're going to put in our own little input here and basically see, does this work? Like, does our input even work properly? Okay, so what we're going to do is this. So enter the location for your letter. So obviously, like, I'm sure you guys can find a better way of saying this. I just wrote this out as something that would at least let me know what the test is. But there are better ways to write this, obviously. There are much better ways, and there are easier ways to write this. So what's going to happen now is let's run it. First, it's going to run this test. I'm going to put in an input. Then it's going to draw out the grid. Then it's going to add the values that I put in from test. And then it's going to print out TTT to show me how it's updated TTT and whether or not it actually has. So let's run that. All right. Okay. So what's happening right now, and what you'll notice is that my graphics thing is like completely glitching. And the reason for that is because I need an input right now. So as soon as I give it the input though, so say I gave it Q. Oh no, it says update grid is not defined. Okay, well, let's just double check. What is the problem with update grid here? I see. It's a little matter of capitalizing, and that happens sometimes. So if it does happen, all you need to know what to do is just double check what specifically has gone wrong here. All right, enter the location for your letter. Hopefully it works at this time. Okay, perfect. So it actually does work. I'll pull this over. What ends up happening is it's a little bit glitchy at first because it's loading, and you do need to put in your input before this turtle graphics screen stops glitching. One here makes perfect sense, so that's awesome because it's supposed to be at the first location. And if we were to draw this out more properly, what we could do is we could say, for I in range 2, and we're going to say, let's spell that properly so we don't get any problems. We can say TTT print TTT at print, sorry, TTT at 0 at I want to print out row by row, so I should say print out at I row 0, column 1, so it should be row 0. There you go. I think that should print out properly. But if it doesn't, it's okay. We can do a quick test just to see how else we'll print it out and whether or not it'll even work. But it should work that way, if I'm remembering accurately. Yeah, there you go. So I just wanted to print out the first 2 values just in order to see whether the 1 actually appears that way. So yes, it should. It should truly appear that way. There's also this, which you might want to do at I and print out T at I. Let's see what happens. I wonder if this will work. It might actually. And if it does, then you guys will get a look at how to print out the whole thing in that form. So let's see if we have Q here. There you go. That's exactly what you want to see. So it looks like that, doesn't it? Looks like the way it's supposed to look. So hence, That's how you can do a little bit more testing. Just overall, remember to check the documentation. And to get this working for 2 players, you'll have to use a little bit more Boolean and a couple of while loops to get it to run more than once. Though we do assume you have a little bit of an understanding of while loops to run the game. So yeah, so that should be pretty much it. Thank you for watching this workshop, and I hope it helps you in terms of doing the actual exercise for today for Code Week. Have a great time.